A three-phase 480-volt line is connected to three impedances of 12 plus 9 Juliet, 12 plus 9 J. Find the power factor. Now, this is one of those problems that you'll be like, okay, you have to remember the basics basically. So the first question you should ask yourself is, what's the relationship between power factor and impedance, right? I mean, you're given voltage, you're given impedance, and they ask you power factor. So what's the relationship? So you know, because we are used to solve power factor problems with having real power P, or reactive power Q, or apparent power, or just using cosine of theta and finding the power factor, but not usually with impedances. So you have to remember the relationship between impedance and power factor. So we can solve this problem two ways. Essentially, we know that if you remember this formula, theta is the tangent minus of x over r, right? And this complex number is written as r plus jx, or xj. And in this case, we know that power factor is going to be your cosine of theta, and therefore theta is equal to tangent minus x over r. So x is 9, r is 12. So if you plug that to your calculator, you will have 3686. Theta is 3686 degrees. So the power factor of that is cosine of 3686, which is equal to 0.8. So you can do it this way, but the other way that I like actually is recognizing that your power factor is the angle of your impedance. So power factor is equal to angle of impedance. And so remember that power factor is angle of impedance. So we're given an impedance of 12 plus 9J. Let's convert this into polar. Plus 9J. Straight from your calculator, I have 15. Polar form, 3686. And of course, the power factor would be cosine of 3686, which will give me 0.8. So I like this way, quickly recognizing that your power factor is the angle of impedance. So remember that. But if you don't, you can always go back to your basic math, calculating the angle when you're given a complex number, tangent minus inverse tangent of x over r. So you can do your calculations and finding. Ultimately, we'll get the same answer. But if I use this method right here quickly, I probably would get to the answer faster than somebody that does this. Same answer, faster method. You always want a fastest method.